Good morning, good afternoon, and good evening. Welcome everyone to this Oasys XDisp Pro and PDisp webinar. My name is Norbert Kovac, and I'm the Senior Business Development Manager at Oasys for our geotechnical software. Brilliant. So with that, you had enough of me. Let's move on to our presenters. So we have Cicera Pereira. She's our geotechnical software specialist. And we have Raul Perulero Serrano. He's our geotechnical product manager. And I will hand over to Cicera. Thank you. Oh, Cicera, you're muted. Yeah, you should be okay now.
Yes, yeah.
Yes.
Good morning, everyone, and thank you, Norbert, for the handing over to me. Welcome, everyone, to today's webinar. This will be about the ground movement assessment with XDisp and its interoperability with PDisp. Today, in this webinar, I will run through quickly on how XDisp works and also demonstrate how to import results from PDisp to XDisp. In part 2, my colleague Raul will then present the latest improvements to the program, as well as how to automate your tasks using the COM interface in XDisp. A small introduction to who we are. As Norbert noted, Oasys or OWE Arup Systems is the in-house software developer for Arup. We currently have structural, geotechnical, and mass motion software programs which are helping engineers all over the world to create optimized solutions for their projects. Our Oasys Geotechnical suite of software contains ALP and PILE, which are our pile analysis software. ALP deals with laterally loaded piles, and the Oasys PILE deals with vertically loaded piles. FRU and GRETA are our retaining wall analysis programs. FRU is for flexible retaining walls and GRETA is for gravity retaining walls. SLOPE is our advanced slope stability analysis program. PDisp and XDisp are both ground movement assessment programs in the Oasys Geotechnical suite. So what we will cover today in part 1 is a short description, as I said, of XDisp and PDisp. The theory behind various applications of XDisp, of course, in brief. An example file, a demonstration, damage assessments with XDisp and a demo, and a small brief note on staging operations and interoperability of XDisp with PDisp. In part 2, Raul will explain shapefiles, what are they, exporting in XDisp and how they can be used, as well as the COM interface, which helps you to use the program to your advantage, as in batch export examples. So we move on. Oasys XDisp is our program which calculates ground movement due to tunneling, excavations, as well as mining. It can then further assess the building utility or rail damages. The typical use of XDisp would be in assessing the three-dimensional ground movements due to tunnel excavations, shafts, retained cuts as in deep basements, or for mined excavations. In comparison, we have PDisp, which is our program, which calculates displacements due to application of a pressure. In addition to immediate settlement due to application of pressure, PDisp can calculate settlements from time rate one-dimensional consolidation as well. So the typical use of PDisp would be to calculate ground settlement due to surcharging, or the settlements of flexible footing or a raft, or a settlement of a tunnel due to loading or unloading. We move on to the theoretical background behind XDisp. So the first application I will explain is XDisp tunneling. So we use the method explained by Eads as shown in this figure. And a tunnel here in XDisp is specified as an excavation of circular cross-section in soil. So XDisp can model settlements in both fine, that is cohesive, or coarse-grained soils. Two-layered systems with level or inclined surfaces can be modeled. Settlement profiles can be worked out due to multiple tunnels, and deformation and strain data plots for lines of any orientation and level above the tunnel axis level can be done in XDisp. The calculations are typically based on the assumption that the settlement trough at the ground surface can be modeled normal or transverse to the line of the tunnel can be approximated by an inverted normal probability curve as shown here in the first figure. And the vertical displacements in the longitudinal direction can similarly be approximated by a cumulative probability curve as shown here in the second figure. So for the transverse settlement, we use this distribution, whereas for the longitudinal settlement, we use the probability curve. So these are empirically based assumptions that have been developed in the past from consideration of monitoring case history data. The two figures are presented in a normalized form. If we move on to see how XDisp models excavation, embedded wall excavations are described in plan as polygons, as can be seen here in this square shape, with a level at each corner or as circles with a single base level. Each wall of the polygonal excavation is assigned horizontal or vertical ground movement curves that are used to calculate soil displacements. Settlements and horizontal ground displacements may be calculated for the construction of retaining walls and for excavation in front of retaining walls to form restraint cuts or basements. So basically in an XDisp excavation problem, we need to tell the program which curves are to be used based on your site conditions. In the program, we have built in surface displacement curves from Syria C580 and Syria C760. But you can also input curves from empirical data or site data if they are available. You can see two curves here as examples. So the curve on the left side is for the installation of a planar diaphragm wall in stiff clay, whereas on the right side is for the excavation in front of a high stiffness wall in stiff clay. So you can see that there are differences in these curves, and therefore it's very important to choose the right surface displacement curves when you're modeling an excavation in XDisp. We move on to see how mining is modeled in XDisp. Here, a mine is specified as an excavation, a rectangular excavation in rock. And the method used is been proposed by Wren et al. 1987, and it defines the surface displacements. So XDisp uses influence functions to calculate the ground movements induced by mining. So now that we have seen the theory behind it, let us now go on to see a file, a demo file which we have set up. It's a hypothetical problem. And the steps to do that would be first would be to set up the problem, whether it is a tunneling problem or an embedded wall excavation, or if it's a mining problem. The input would include the tunnel or the excavation dimensions, and then the displacement locations where we will tell the program where the displacements have to be calculated. The output would include the displacement in X, Y, Z directions, both in the tabular form as well as charts, which can be exported to CSV and used for further calculations. I'll just end this presentation and go to the example file. I hope my screen is visible.
Yes, we can see it.
Yeah, Okay, so this is an example that I have set up. And once you open up XDisp, you can see this is what we call our ribbon menu. And this is quite intuitive. All the menu items can be accessed from here, as well as from our input explorer, which is on the left side of the screen. So this input explorer has been modeled in such a way that if you go in the serial order of this input explorer, all the inputs can be done in a correct and uniform manner. So the first would be to input the titles and units. If you click on the titles, you can input your whatever details have to be input here. So this can be printed out while you're printing out your results as well. So we can close each of these tabs or keep it open if needed. And there are a number of units options available. You can just click through and check whichever is suitable for your project. The next one is the specification tab, where we have to select whether it's a tunneling problem or an embedded wall excavation. So in this example, I am going to click tunneling or embedded wall excavation, as I'm not demoing mining now. We can close this tab. And polylines is the option where we can input polylines if needed. The next step is to input the displacement data. So in this example, I have input 5 lines. So these are the lines along which I expect some utility to be there, or I need the program to calculate the displacements. So if you look at the 3D graphics screen, we have two options here, home and graphics. So if you go to graphics, you can see that the tunnels, excavations, and the displacement data are highlighted, which means I have input one tunnel, one excavation, and displacement data, and all of them are showing in this screen. If you want to click any of them off, you can just click on the item and the grids will be turned off. It's a toggle tab. So if you want to see, if you do not want to see the lines, you can click them off, you can click them on as per your requirement. If you don't want to see the tunnel, you can click them off and the excavation as well. So these are toggle menus. And so now that we have our lines ready, and I can see that I have input 2 grids as well. These are just basic data, which is start and end. And the extrusion, you can please refer the manual. So this is how we will define a grid in XDisp. So you need to draw a line along the x-axis or along the y-axis and extrude it in the perpendicular direction so as to create a grid. So 2 grids are there, as you can see here. If I look in this, this is just holding the mouse and moving it around. So it's very easy. So you can see 2 grids there, one on top of each other. Also, I have input a tunnel. So here, if you see the tunnel details are the diameter of the tunnel, the endpoint 1 and endpoint 2 of the tunnels, and there is a ground loss parameter which we need to input, which is also explained in the manual. It is based on the method of tunneling and various site conditions. Then we do need to provide a K value, which is also a constant, which is provided based on the type of soil you are going to encounter. The analysis method is near at all, and then the ground level needs to be specified as well. So the tunnel is already input. The next one will be to input our polygonal excavation. So here the excavation dimensions are input manually. So you can see here that it is a rectangular excavation and the coordinates are input accordingly. The next important thing is to assign curves to the walls of the excavation. So if you click on ground movement curves horizontal, you can see that new horizontal movement curve can be input. A new horizontal curve movement curve can be input as required, or you can choose from the input Syria curves. So these are the Syria curves which have already inbuilt into the program. So you can choose any of these. In this example, what we have is a curve which has been sourced from a 3D FE model for ground movements around an embedded wall excavation. So this has been sourced from a previous project, and I have input the data as a horizontal assignment curve. So for vertical also, the same Syria set of curves are available. You can choose as per your project or site condition. And here what I have done is I have put in data which we have already sourced from a 3D FE model analysis. So those curves are now to be assigned to the ground movement curves. So that is what we have done here. You can click here and assign any of those curves which are suitable for your project. So now I have assigned the vertical curve which we have input and the horizontal curve which we have input manually. You can also choose any of the Syria curves that are available. So now we have done the displacement data and the excavation and the tunnel. So now we are ready for analysis. I'll just close this one. Okay, so then we are ready for analysis. Okay. So now you can see that the analysis is complete, and what is now visible is the deflected shape. So if you go to graphics and you click on the deflected shape, this is also a toggle button. So you can see that the deflected shape is shown, deflection of the grid due to the excavation and due to the tunnel. So if you are in a meeting and you want to show the client how the deflected shape of the soil would look like once excavation is done, then this is an easy method. If we go to plan, so you can see the plan here. The grid is shown. The displacement lines are shown here in with crosses on it, and the excavation, the rectangle excavation, as well as the tunnel. To see the contours in clear, so we can put the filled contours in. So you can see that the displacement approximately at the center of the tunnel is around 20 to 25 mil, and the excavation is also shown here. So if you want to check the settlement at any point here inside the contour, you can click on annotation and click wherever you want the value to appear. So these are the values. So at the center, you can see that the settlement is around 23.36, and here, as it goes away from the excavation, it's much lesser. This is the graphical output. And if you go to the Explorer, you can see the Output Explorer here. And all the results in tabular form can be seen here from the from clicking on the lines or the grid. So each of these lines will be shown separately. So the displacement in X, Y, and Z direction are all here. And or from the grids as well, or from the grid points as well, it is here. So grid 1 is here. And if you click on the plus, you can see the grid 2 as well. So the tabular results are there, which can also be exported to CSV very easily, and you can convert it into Excel as well. So this is a tabular form output and the 3D output in graphics as well. So that's what I wanted to show you in this section. So I'll just close this one and go back to the presentation. Okay. Next, we will be seeing how XDisp can perform damage assessments. Building damage assessment in XDisp is carried out when we need to assess whether the proposed construction works, for example, tunneling works or excavation nearby, would affect the existing buildings in any way or utilities. So this is helpful while tendering also, as it is possible to assess at least roughly the amount to be anticipated for repair works. So categories of damage can be found out using the displacements that has been worked out by XDisp models. So XDisp, what it does is it calculates the tensile strain on the building, and that correlates to the approximate crack width, which can then correlate to the cracks and the severity of damage. So this has been developed from observation of several case studies. The commonly used system proposed by Burland, it describes the category of damage as negligible, very slight, slight, moderate, severe, and very severe. So you can see that from 0 to 2, it is negligible to slight, which affects the visual appearance and aesthetics of the building only. Whereas if the damage category is 3 and 4, it is moderate to severe, and the building damage is quite extensive. But if the category is shown as 5, then or it is very severe and it affects the stability of the building. If the building locations and properties are known, then specific building damage assessment may be performed to calculate damage categories for precise locations. But for example, if we do not know the locations where the buildings are located, then a rapid general assessment of likely building damage across an area that can also be done. So for this, we need to draw a polyline like this along the area where we expect buildings to occur and draw equally spaced transects along this polyline. So what happens is the program will now calculate displacement, strains, and damage categories for each of these transects because the program will assume that there are buildings along these transects along the polyline. So that's how we do a generic building damage assessment, as opposed to when we know the exact locations of the buildings, we can do a precise building damage assessment and understand what is the damage category for that building only. Similar an assessment can be done for utilities as well. So here in utility, we need to input the utility location and the utility dimensions, and the output will be calculation of strain, the pull out and joint rotation. As we have seen in the building damage assessment, the program calculates strains and then tells you which category the building damage falls in. For utility, it will work out the strain, the pull out and joint rotation and compare it with the acceptance criteria given. So we can provide in the program acceptance criteria based on the project specification or previously accepted results. So the program then will then compare it with this acceptance criteria and show you whether the utility is passing or failing. Similar to generic building damage assessment, generic utility damage assessment can also be done in the same manner by drawing a polyline and then showing the location of the transects. So for each of the transects, we can assume that a utility might be present along at the location of these transects, and then the program will calculate the strain, pull out and joint rotation for each of these, compare it with our threshold values or limit values and tell us whether the utility will pass or fail. The latest addition to the utility damage assessment is the assessment of tracks, railway tracks. So the alignment of the railway tracks can be described by polylines, and acceptance criteria specify the threshold and limits for cant and twist. So assessment intervals will now define how frequently along a rail track calculations of cant and twist are performed. So as you can see in the figure, L is the span or base for the twist calculations, and delta is the difference between the vertical ground movement at center level of each assessment interval, and C is equal to delta 2 minus delta 1, that is how cant is calculated, and alpha is the twist or the change in cant over the span base. So now we have seen the damage assessment theoretical part. Let us now look at an example. So this is a file, is a model similar to the one we had seen before. Only I have taken one grid out of it. There is only one grid now, as you can see. And I have input a building, a sample building here and a utility here. It's a pipeline going up to the external part of this excavation. And there is a railway line as well. So you can see that there is a railway line, a utility, a pipeline. The tunnel is there, the excavation is there, and a building location is also specified. So if I analyze it, by the way, sorry, In the building damage assessment, the damage category strains need to be is already built in. So Burland strain limits are already given. So we do not need to specify any damage category strains. Now for the utility, we need to specify the acceptance criteria or the parameters. So here, as you can see, the acceptance criteria 1 is provided for pull out, rotation, and the strain. So here you can the program allows you to put 2 limits for the threshold and the limit options. If you do not want to check on the threshold, you can also click on no and check only for the limit. So for each of these, we have provided the acceptance criteria. So based on these acceptance criteria, the program will now check whether the utility is passing or failing. So now we can analyze. Now, if we go to graphics, you can see that the tunnels, excavations, all these are the same as I have shown before. But for damage assessment, we can click on the settings wizard, right click on this on the screen, and the settings wizard will come up. So here for building damage assessment results, we can click fill, and then if you apply, you can see that the building is shown in a yellow color. I'm not sure if the color shows up here, but category 3, sorry, the yellow color corresponds to category 3. I can show you that in the graph a little bit later. So this building is now showing that there is a moderate damage category, and maybe we will require some work to be done after the excavation of the tunnel, and this excavation is done. Now moving on to the utility damage, you can see if I click on rotation and apply, you can see that this utility is also in the threshold failed limit. So the yellow color shows as per this, you can see the legend here, green is pass, yellow is the threshold failed, and red is the limit failed. So the utility is not failing in the limit, the maximum limit is not failed, the threshold limit has crossed. So if you check the pull out and click apply, you can see that it is green in color, which means the utility is passing the pull out criteria. And if you look in the strain, okay, so now you can see that the limit has failed in tension. So that is how you check the utility damage results in XDisp. Now, if you go to the rail damage results and click on CANT, for example, you can see that it is green. I'm sorry. Yeah, okay. So this is green in color. So that means it is still passing. And the twist is also green in color, which means it is passing as well. It has not failed in any of the criteria. We'll just go and have a look at the graph. So the building damage interaction chart. This is the building damage interaction chart, and in black you can see the maximum strains that the program has calculated. So the maximum strain here at this offset 0, 0 is between green and blue, which is green category is negligible, and very slight to slight. So here in this offset it is showing here, but in our in the picture that we saw in 3D graphics, it was showing moderate because in this offset, for example, the strain category, sorry, not this. Okay, so here this category is going on into the moderate region. So that is why it was being shown as moderate in our graphics. So that is the damage assessment, how we do damage assessment in XDisp. So now we go on to the next part of the presentation. Which shows the staged construction. XDisp allows modeling of stages in construction. So if you look at this GIF, you can see that when the pilot tunnel is drilled, the second building was still green, and when the next stage of the tunneling, the diameter has increased, the building becomes red, which means it is going to the severe category. So when we start modeling a project, the existing building might be in a category which is safe or negligible, but when the construction proceeds or the tunnel is enlarged, then the building might become into a severe damage category. So this has to be considered in the project works. So when do we need a staged modeling in XDisp? When construction changes occur during work progress, or if you want to consider different design options or analysis cases. So if you consider one design option, is the building in the severe category or is it in the negligible category? The same applies for utilities as well. So you can consider different design options or analysis cases. And when the tunnels or excavations, some tunnels may be needed to be included or may be excluded in different stages. In that case, you can model a staged construction in XDisp. Also, when you specify varying tunnel diameters, just as we saw in the GIF, or excavation depths, for example, when you excavate only part of the excavation, the utility might be safe, or when you go deeper and deeper, the existing excavation utility may fail in any of the acceptance criteria. So pilot tunnel later expanded to the full tunnel diameter, yeah, and deepening of excavation. So these are the cases when XDisp staged construction models can be done. The next point is how we can use PDisp along with XDisp. So now new improvements in both PDisp and XDisp has now made it possible to use both programs in conjunction with each other. So PDisp, as I said before, calculates displacement and stresses in the soil due to applied loads. But as we have seen, XDisp cannot analyze the effects of loads. So therefore, if you want to calculate the displacements near excavations due to loads, then you can use the same displacement locations and import the results of one program to the other. I'll just do a small quick demo. So here is a PDisp file in which what I have done is I have now imported the grids from the grids and locations from our XDisp file to here. So you can see that the lines are the same and the grids are the same. So for the interoperability between PDisp and XDisp, we need to make sure that the displacement locations are the same. So now what we can do is we can analyze this file. Okay, now we have the results of this. And now what we do is we go to the XDisp file and click on export. Import the PDD file. PDD is the .pdd file is the PDisp file which we have run there. So this is PD1 and I open it here. So now it will ask whether it needs to import the displacement locations or the displacement results. We do not need to import the displacement locations because it's already there in the XDisp file. I need only the displacement results. So now what I do is I will click on OK, and it is telling me that it is going to import 4039 displacement results from the PDisp file to the XDisp file. So now if I click on yes, you can see that the results are already exported. So now you can run the XDisp file as before, and now you will have the combined effect of the load and the excavations in this same file. Okay, so now we go back to our presentation. So that's how we combine XDisp and PDisp. So with that, I will hand over to my colleague Rahul to continue with the presentation, and thanks for listening.
Thank you, Cecilia. I'll just pull up the presentation. And please just let me know if you can see it. Thumbs up on the would be good in the chat, if that's okay.
Yes.
Yeah, we can see it.
Thank you. Perfect. So yes, so a bit of focus today on shapefiles. Pretty sure you might have come across voluntarily or unconsciously, both at work and out of work. But it's part of the revisited features on XDisp that the team has been working hard, the development team. And without further ado, I'm just going to show you. So what are they and why are they useful? And also how you use them how can you use them in your projects, and how this can be helping to present the results to your clients. And then also what's new about shapefiles in XDisp, and how can you take advantage of this new functionality. So a shapefile, by definition, is vector data file format that normally is used for geospatial applications. And a shapefile stores things like points, polygons, lines, and data associated to those. So here in screen, normally it's composed by it can be composed by a lot of different types of files. The bare three minimum ones are SHP, SHX, and the DBF, which basically contain all the information to represent that geospatial data on a map or on a base map, and a couple of extracts from one of our sample files on XDisp on the left. So you can see results of your run model, for example, in a 2D like from the top view or the plan view. We can also look at the same information or the same results when we are looking 3D. And those contours, those infield contours, but how you translate that into a different software where you can overlay over a picture of your site, for example, and to represent those contours, how could impact, for example, the buildings, rail, utilities. And that picture on the that graph on the representation on the right hand side is the structure. So for example, you can get to represent those lines, those points, associate with some entities, and how that structure is conforming with these three files. Surely you might have come across, for example, in weather, for example, on weather, or for example in weather websites, or for example information websites where you can about locations, and more closely to geotechnical engineering. For example, I can just think about the BGS index of boreholes. You can find the polygons, for example, for different geologies. You can see the borehole records. Though that information is stored in this type of files, and then it can be represented over a base map. So what's the workflow? What's the typical workflow of exporting shapefiles in XDisp? So it basically is 3 steps. You run your model. You can query the results through the graphical output in the tab inside the interface, and also within the interface you can just, with a couple of clicks, you can export those shapefiles to your machine. So how does that work in the functionality that we are releasing soon? We did this. We revisited the functionality because we had some feedback with our users, and it was a bit of a pain point. And we found that we could do better, and we've simplified the process. It's streamlined now, and it's got more options as well on how you can export those files. So what you can see here is a GIF, and how you will be soon able to do this. You just go through the settings wizard, and you can select the lines, the grids. In this case, is the grids because you've got the information set on a 2D. You can select what's going to be the export magnitude that you're after, and then just a couple more clicks, you select the grid that you want. This particular case, it's got a single grid, and then you just save it in your computer. That's as simple as those 3 steps. And there we go. So now, what do you do with the shapefile once you have it? If you try to open it, for example, with a file editor, you're going to struggle to read through it because it's encrypted, so it's got lots of funny symbols around it. So the best thing you can do is use GIS software, so Geographical Information System. Typically, companies like Esri and Esri also developed and created this the shapefile format for interoperability with other software. And what you try to do with it is get that same information, overlay it on top of an existing map of your choice, and then you can also bring it ready for a report. And again, just there in screen, the typical workflow you would use in the software of your choice. For this, you add that base map layer with your site, then you've got you can import the shapefiles with the results from XDisp, with the settlement contours, and then you just create everything around it to make it ready for your reports. So here a bit of a snapshot of what can be done or how. I've used in this particular instance QGIS, which is an open source software. I've used a default map overlay. I'm selected also the coordinate system that where my results are going to be plotted correspondingly. This one in particular doesn't have associated coordinates on a particular place. It's 0, 0, 0 on the longitude and the latitude. So it's in the middle of the ocean, as we could see. And then once we've imported the shapefile, and we can just check through the results through the attributes table. One thing that we can do as well is recode the colors, because it's imported as just as polylines. And then what happens is you can easily, with a few clicks, recode this, reclassify according to the values that we've recorded in this particular case for settlement vertical components, so the Z displacement from XDisp. Then you do this reclassification. You choose what sort of, for example, color scheme. You can make it make it visually friendly for all sorts of users, and then voila, you've got it there. Again, with a few clicks, and then obviously there's more once you make it report ready. But it allows you to understand if the results you're getting from XDisp and how that affects on your site. And now moving into automation, COM interface. So how this can help you in automation in your workflows. How can this make your life easier, and also like saving lots and lots of time when trying to export results. For example, when Cecilia was showing in her part of the presentation on checking on the results, the different like curves and on the damage assessments. If you think that you've got a single stage, a single model, and a single building, fair enough, you can do that manually. But the moment you start having a multi-stage sequence and with lots of utilities, lots of buildings, you might want to optimize and streamline the process. So that's how the COM interface can help. So the COM interface is a shared functionality across the Geo suite in Oasys, and it's documented within the help and user manuals. You will find more information there. I'm going to just do a brief introduction to what's the COM and also the JSON file format. Then also I'm going to move on to show you a few examples on how can you speed up the process, and then some further links for further reading and references on how you can make the most of it. So what's COM? COM stands for Component Object Model. It was developed originally by Microsoft in the early 1990s. It's a binary interface standard for software components, and it's used to enable the inter-process communication between object creation and a large range of programming languages. So long story short, is a way we can speak to the computer, ask through scripting, through a bit of coding, take advantage of automating processes that otherwise you would have to manually do one after the other, like in sequence. And then we're going to, it's a way of doing the same thing, but just in a more modern way, if that makes sense. Then JSON file. So JSON stands for JavaScript object notation, and is an open standard file format and data interchange format that uses human readable text to store and transmit data objects consisting of attribute value pairs and arrays. Again, long story, encapsulating the concept, and probably it's easier just from here. Once you have an editor, a JSON editor, for example, Notepad++, you can also do it. There are also some tools online. What's happening there is you've got a nested structure of attributes and information attached to it, and it's human readable. So it's a way that we you can export the binary files and the native files of any of our software to JSON, and then you can use and modify those files and then rerun these outside the main graphical user interface. So that gives you flexibility on your work. So Visual Basic, Python, you can choose the scripting methodology, and we ship in the sample files in the folders of after installation. You will find some sample files that we've provided for easiness on getting started on this. So we have documentation inside the user manuals. There are sample files that can help you with some easy initial examples, and then you can elaborate as much as needed in there, and you can learn from it as well if you're new to it. Then two particular examples that I'm going to show with a GIF following this slide is saving multi-stage results. Again, if you've got a single project with a single stage, it is different, but once you start increasing the amount of stages and different amount of buildings, utilities, it ramps up very quickly the amount of post-processing required, and this saves time in very quickly. And then also about in batching export of images. So as you can see in the screen, I did it on a couple of folders that were originally empty. I've got on the background a Python script that consists in about 20 odd lines of code. That's as I mentioned, these sample files are already in Visual Basic and also Python language in our software in the samples. In the samples folder, and once these scripts are run, there's an input of results, for example, in CSV format. And once you open those CSVs that you could manually do, you just have all the results here, and then you can also do some automation around it to extract those results and then carry on with your post-processing and reporting of results. And then also I did just showing there as well what happens when you do the same but with images. So in the order of 100 images have been exported straight away and in minutes. So it's very, very quick. And yeah, without further ado, some more references. As always, go back to the manual. Always welcome to get your queries if you want to know more. You can contact us. And then also we've got past webinars from Oasys on practical applications of the COM interface across the Geo suite. And I think that's all. Thanks so much for your attention. I'll hand it over to you, Norbert.
That's brilliant. Thank you very much, Raul and Cecilia. And as we have 10 minutes left and quite a few questions, I will be quick. So first question, can you elaborate more on the methods of analysis for excavation in XDisp? Cecilia, this might be a question for yourself.
Analysis for excavations in XDisp. Yeah, so we do have different types of excavations available to be analyzed in XDisp. As I showed, you can input circular excavations, polygonal excavations. The only thing to be careful while analysis in XDisp is to choose the correct horizontal or vertical curves that you need to assign to each of these excavations. All this is explained in detail in our user manual as well. And if there is any further help needed, please do get in touch with us, oasys@arup.com.
Brilliant, thank you. So the next one is, what is the difference in function between a polyline and the line in the input data?
Okay, so I'll answer that as well. The difference in function between a polyline and a line. I assume that you mean the displacement data. So polylines are used for inputting the data regarding railway lines, railway tracks, when you have to run a damage assessment. And a line is, for example, it's a normal line. Raul, please correct me if I'm wrong. A normal line which is input for the location of display or for utilities where you will tell the program to calculate the displacements.
Lines tend to be like just between two different points, so as poly and into the as well. But in polylines also it's broken up. Like it's composed by different lines. That would be the
yeah. Okay. Yeah. It's a composite line, actually, a polyline. Yeah, that's right. Thank you.
Okay, so moving on to the next one. How is it to use the automation tools available in XDisp and PDisp? So Raul, this probably yourself.
Can you say that again? Sorry.
How easy is it to use the automation tools available in XDisp and PDisp?
Right, how easy? Well, that's that's kind of
that's
personal.
Very subjective.
Right. So background, for example, for myself, I've been before becoming a product manager in the making. I've been a geotechnical engineer for a few years, about 5 years. I come across different projects, different sizes, and one of the things that personally kept me of doing more sometimes, it was the repeatability of things, like how many processes took once and again, and manually doing this, doing that. And when you have a single project with a single file, a single stage, something that is easy. How easy it is. I've learned on during my years, I've learned a bit of Python. I've learned to read a bit of Visual Basic. It's like reading. It's reading and it's a language, so you need training. So it's something we've provided in the past as well. If you would like us, for example, to query further and successfully, so we had really good feedback from our users, and it all starts with how much you need it in the process, how much you need to learn. For example, at the level I need it, I just need to change, for example, like file locations, because and I tend to ask help, for example, when it's more complicated, to more knowledgeable colleagues across the company, which I'm pretty sure might be the same case for you. It's to me now, it feels easy, but as a user, and not just as a user of scripting, it takes time to learn it. But once you are into it, is a language. You can read through it. You can understand what's happening. You can query its actions. Is like to do this, I need to do these other bits, and is just like nested structures of different actions, and then you get an output out of it. And the effort that you might need to put personally to get to that level, it's worth it. I can say that it's worth it. It's worth the effort.
Brilliant. And also that would be applicable for any of our other software where you can use scripting. So you wouldn't just learn it for one, but you can use it more generally. Okay, so next question. How does the program take into account the stiffness of structures, or is it greenfield only?
Yeah. For the assessment of ground movements, it is only greenfield. Greenfield calculations are done. Yes.
Okay. Next question. Can we import an actual ground profile as grid?
Yeah, for this, I was just discussing with our senior developer, Vikram. He says that we can import the background for PDisp, but currently not in XDisp. So we will consider that in future as well.
Okay. The next question seems to be very similar. Can we import a background plan layout of site in XDisp and PDisp? So, okay. How are the displacement fields calculated in PDisp and XDisp added combined?
Sorry?
So how are the displacement fields calculated in PDisp and XDisp added/combined?
Yes, we need to have the same displacement locations in PDisp and XDisp. They need to be identical. And once you know the loads, you can analyze it in PDisp and you can carry it over to the XDisp model. The model will then combine the effects of the PDisp as well as XDisp.
Brilliant.
It takes the combined components and you get the X, Y, and Z components, and then puts them together, adds the field from PDisp into XDisp. So that's how it merges exactly as it said. Many
Sure.
different
So
levels.
how does XDisp assess building damage assessment without considering the combined effect of heave due to basement excavation and settlement due to pile installation and wall deflection?
Vikram, are you on the
Oh,
in the meeting?
Vikram is on mute.
Yeah, sorry, I have
There you go.
unmuted. Sorry, yeah. It is possible to do stage analysis in XDisp. Like you can have different stages modeling the different aspects that the user is talking about. Something is heave due to basement excavation, then similarly the wall deflection, etc. So for heave related to basement excavation, I think the closest alternative that we have is from importing the data from PDisp, where we can do some approximations using a negative loading at some level below the ground to simulate the approximate heave field. And other thing is like the wall deflections, like Sisira mentioned in the webinar, we have some pre-programmed Syria curves. Otherwise, that particular component of displacement field, we need to get it from other software such as Sprue, Gopher, which give you the deflection profile of the ground in relation to stage excavation. So then you can combine both of them together, as explained by Sisira earlier, by making sure that the grids are aligned properly and the data is also present at the correct locations.
Brilliant. Thank you for that. And I believe that was the last question we had. Just to let you know, in the meanwhile, if you have any more questions, you can put them into the chat box or the Q&A. But just to let you know, the session was recorded, so you will be able to review this on our website. And for any of you who are new to XDisp PDisp or any of our software, we do provide free trials, which are 2 weeks long, and you can request this through our website. So through our website, or you can just send an email to oasys@arup.com, and we will get back to you. Okay, so we finished bang on time. Well done, everyone. Okay, so if any other questions come in, don't worry. We will send out the replies to these. I just want to thank everyone for coming along, especially if you had to stay up late or wake up very, very early. It's much appreciated. Thank you, Sisira, Raul, and Vikram for all your help. And yes, we will finish off here, and we'll take it from here. Cool. Thank you all for coming.
Thanks, everyone. Take care. Have a good day.
Thanks, everyone. Bye.
Have a nice day. Bye.